So in this video, we are going to discuss about Stefan-Boltzman law. See, this Stefan-Boltzman law is the governing law for radiation. Now, this Stefan-Boltzman law states that the emissive power of a black body, so emissive power of a black body is denoted by EB, is directly proportional to fourth power of its absolute temperature. So, emissive power of a black body is directly proportional to fourth power of its absolute temperature. Suppose if we consider this object as the black body, so this black body has certain temperature, and here we need to consider the absolute temperature, that is in Kelvin. See, every body emits certain amount of energy. So as this is a black body, this also emits certain amount of energy, and that energy we call it as the emissive power of the black body. Now, this emissive power of the black body is directly proportional to fourth power of its absolute temperature, that is given by the Stefan-Boltzman law. In order to remove this proportionality, we need to introduce a constant, and that constant we call it as Stefan-Boltzman constant, and it is denoted by sigma. Here, this sigma is Stefan-Boltzman constant, and the value of this Stefan-Boltzman constant is always the same, that is 5.67 into 10 raised to the power minus 8 watt per meter square Kelvin power 4, where this emissive power EB will be in watt per meter square. So per unit area we are going to consider, and T is absolute temperature in Kelvin. Now, see, this Stefan-Boltzman law is talking about only the emissive power of the black body. Suppose in order to have heat transfer by radiation between two objects, let us say there are two different objects which are at different temperatures. Let us say the absolute temperature of the first object is T1 and that of the second object is T2. Suppose if T1 is greater than T2, heat transfer takes place. Suppose let me consider that I have kept these two objects in vacuum. Then the only means by which heat transfer takes place from the first object to second object is by radiation. So heat transfer Q1 to 2 is happening only by radiation. Now, if this is the case, Q1 to 2 heat transfer will be equal to sigma into area of the first surface from which the heat transfer is taking place, multiplied by, here depending upon the shape of the surface there will be a factor called the shape factor or the geometric factor. So that we need to consider. It is denoted by capital F1 to 2 multiplied by, see, these two objects which are at different temperatures will have different emissive powers, and if we consider that these two bodies are not black bodies, then what will happen is these two objects will possess different emissivities. So emissivity is denoted by epsilon, which is nothing but the emissive power of the given body to the emissive power of a black body. Now, see, this emissivity value ranges from 0 to 1 depending upon the type of object that we have considered. Suppose if we consider these objects as white bodies have zero emissivity because white bodies simply reflect the energy. Then black body, if we consider, it will have emissivity of 1. The remaining objects are colored bodies or gray bodies, whatever you call. So those will have emissivities in the range of 0 to 1. Now, as these two objects are having different emissivities, we need to establish an equivalence between them. So, that equivalent emissivity, sometimes we call it as interchange factor. It is denoted by small f122 multiplied by T1 power 4 minus T2 power 4. This is going to give us the heat transfer. So this is the formula for heat transferred by radiation, where capital F122 is called the shape factor, small f122 is called the interchange factor, or equivalent emissivity. See, as these two are factors, they doesn't have any units. Now, so let me write this heat transfer equation like this. Q is equal to sigma A1 capital F122 small f122 into T1 power 4 minus T2 power 4 is there. So let me write this T1 power 4 minus T2 power 4 like this, T1 square minus T2 square multiplied by T1 square plus T2 square. And we can also split this like this, T1 minus T2 into T1 plus T2 multiplied by T1 square plus T2 square. So therefore, finally this equation becomes Q122 is equal to sigma A1 capital F122 small f122 into T1 minus T2 into T1 plus T2 multiplied by T1 square plus T2 square. See, why we have written like this is in order to get this particular expression T1 minus T2 by 1 by sigma A1 capital F122 small f122 into T1 plus T2 into T1 square plus T2 square. Now, if we relate this with Ohm's law, as these two laws are analogous, Ohm's law states that I equal to dV by R. Current is because of potential difference and the material offers resistance to the flow of electrons. Here, heat transfer is because of temperature difference and the resistance offered here, we call it as thermal resistance, and this thermal resistance is due to a radiation effect. So this is the formula for heat transfer by radiation we need to remember.